Hello community. I want to know, how does the O3 model from OpenAI, how does it function inside? What is happening here to this reasoning process? And I want to look at the complete model. So I start with the pre-training, with the supervised fine-tuning, with the DPU, the reinforcement learning, and I look at particular then at the inference time reasoning process. And I do have a guess. And I think that they are all connected. And this is the worst case scenario, because then we have to optimize everything. The fine-tuning, the reinforcement learning, and the inference time reasoning process, so that we have a complete coherence in the process for the optimal jump in the performance of the O3 model. So let's find out if this is true. Because I think there are dependencies in the fine-tuning process and in the reinforcement learning process that directly impact the performance of inference time reasoning. Now, how to explore this is easy. We look at the documentation and we use a little bit of our own brain cells to do this. So, very easy idea. We go step by step. So first, we implement now a particular data set, a particular reasoning set here. Let's call it safety in our supervised fine-tuning methodology only. So the safety data set is only implemented here in the supervised fine-tuning process, and there are no safety data that we provide here to the reinforced learning process. We can do the opposite, no? We can have no safety training data for the supervised fine-tuning, and all the safety data go into the reinforcement learning. And you might say, hey, this might be even better because reinforcement learning is the topic right now in AI, no? Or we say, you know what? We could experiment and put the safety data in the supervised fine-tuning and particularly selected here in the reinforcement learning. So I have my safety data implementation in both supervised fine-tuning and reinforcement learning. And you know, it is easy because OpenAI shows us these results. Of course, the link that you would assume whether you find the data by OpenAI is not really asset, CTF, assets.net, and then a little bit of a complicated link. No, but who cares? We have the data and they are accessible. We just have to find the data. And those are the result. And we just look at one problem here, jailbreaks of LLM. And there are the data. Look. If you have no safety training, for this particular benchmark, we have here the test score. 20%, 40%, 60%, 80%, 100% success. So I go here 44%, great. Then if you put the safety data in supervised fine-tuning only, we have 81. Only in reinforcement learning, we fall back to 73. But if we optimize now supervised fine-tuning and reinforcement learning with our particular reasoning data set, how to cope with jailbreaks that affect the safety of our AI systems, we have 87%. And then you say, of course, hey, what if you have here just in inference time, I don't know, in context learning or whatever we go methodology for, how good is it if we just provide here the complete book of how to improve here the safety against jailbreaking? At inference time, we are at 80%. So this is the second worst result, but close to supervised fine-tuning. And now comes the point where I ask myself, can I understand what's happening? Because I want to have a look inside the O3 model. So let's think about this. So those are now the data. And I thought about, but wait a second. The way I present now the training data, this is crucial because, you know, I have the data, but I have the data also in a specific format that is here a particular pair of instruction that is optimized for a chain of thought and for multiple chain of thoughts. So let's say you have your company documents, or OpenAI has here its documents, how to prevent jailbreaking, how to improve the safety, how to improve the alignment of the AI that it behaves in the way you want. And if you have this, and let's call this now the reasoning data set on a particular domain that you want to have implemented, and we call this domain safety. So again, if we take care about the data, the instruction, but we provide the instruction in a way that the system understands that this is a chain of thought argumentation, then we have a win-win situation. Yeah? And then I thought, but wait a minute. If OpenAI shows us this on a particular document about safety procedures, where we have the data and the way we expect the system, the AI system, to reason, what about we have the medical data? And I give here all the medical documentation here to AI, to OpenAI, and say, hey, this is now my instruction data set, how I want that you perform medical reasoning, and I give you also the medical data for the reasoning, and in the simplest case, we go with a chain of thought. Or I might say, hey, I'm operating in finance. I have here all my financial documents, how I do analyze documents from finance, how I do projection into the future, what are my main characteristics, what are my benchmarks, what are my parameters that I have a simple Python program for that I can connect to whatever, or I have a prologue where if we have some logical decisions to do, we have function callings and no problem at all. So if we have, or if you have in your domain, your data and your reasoning apparatus, we can do now the same. So you see, I just use here the data that OpenAI provides for the safety reasoning implementation. And yeah, I think, hey, why not can we implement this for a financial reasoning implementation or a medical reasoning implementation? Or of course, a theoretical physics reasoning implementation. Yes, we go there. But first we have to answer the question, how to encode this data? What are the dependencies between the different methodologies? Can I say the first two are independent and I just have to focus on the last two? Or is this simply plain wrong? And therefore, I have not just to encode this for supervised fine-tuning, reinforcement learning, and a combined effort that has a high coherence, but also how to encode this for the inference job that I have for the test time training or the test time compute. And here I noticed, reading now the publication by OpenAI on the safety measures, that I made a mistake. I went here with the classical DPO, direct policy optimization, but I noticed that OpenAI is not using this because they argue here, this skips here the reward model, and they use in their implementation of the latest safety reasoning chain of thought guidelines, they say we need a reward model for this. So we fall back now to the old classical reinforcement learning by human feedback. And I said, great. And then I read more paper about it. And then I noticed that OpenAI is moving directly into a reinforcement learning by synthetic data feedback only. So they say, hey, yeah, we don't have the humans that are specialized on all different topics, and it's maybe simply even too expensive to pay, 100 or 1,000 real grade A professionals for for safety improvements. So therefore they say, what is a methodology that the AI can find out themselves so that we only have synthetic feedback data? And they found a way. But more about this later in my next video. So what we have now, I understand we are going now with pre-training, supervised fine-tuning, reinforcement learning on synthetic feedback data generated by AI. And then we do have a real strong dependence, both models here, on the inference time reasoning capabilities of O3. And O3 compared to O1, there is something happening here. And now we start to understand what is happening. Interesting, if we read more paper, and I'll show you this in a minute, we find out that this reward model is quite essential to the performance of O3 and O3 Mini in particular, because we will use this reward model 2 times in the reasoning process, in the inference time reasoning process, and it has a direct back link here to the before inference time reasoning. So just to make it a little bit more abstract, so what we do is, we have here a combined coherent effort to train here the supervised fine-tuning and the reinforcement learning on synthetic feedback data that we generate with an AI system. We implement here a particular reasoning methodology. In the OpenAI documentation, you find they only show you this on the safety because they want to show the world and their investor and the regulatory, national authorities how safe the new O3 model is. Yeah? So therefore, there are more transparency on the safety implementation, but they don't want that their competitor understand exactly what they are doing. But hey, yeah, we have this little brain. So I use my little one and I see, okay, so the reasoning methodology that they apply here is classical, in the minimum case, a chain of thought. We can go later to a forest of thought implementation for our own open source O3 model. Great. So we see now, and we implement this methodology, chain of thought, in both of them in a combination that it has a coherent performance that is close to 87%. But this has also a direct influence now in inference time reasoning. Let me show you why. Yeah, I have just to tell you, to be correct here, that they also have here implemented here a AI model that judges the quality of particular reward streaming data. So we rely, I told you want to generate here syntactic data. So somebody has to choose the best syntactic data from a syntactic generator data set. And of course, OpenAI goes here with a AI judge model. More about this in my next video. Great. So we have here O3 mini, let's say this. And what is happening now if we have this coherence? And I did not understand for the long time, how is this inference time reasoning depending on the particular supervised fine-tuning and reinforcement learning methodology? And then I thought about it. So what's happening in inference time? You know, this famous 13 minutes that we have now in the O3 performance mode, thinking about a problem. We have now our real prompt, the real task by the user. And now the system goes back to its trained model and says, okay, so now I start to generate multiple solutions, multiple reasoning paths, multiple complexities in my answer. And so this is our O3 mini. And I want to indicate, here O3 mini comes to the first set of possible solutions. And then we have 13 minutes. So O3 goes on and goes maybe to a next level, higher complexity set of solution. And if you want to see this in action, I think here from Hugging Face, I would recommend this literature, December 16, 2024, Hugging Face, those are the authors. Here you'll find the link, Hugging Face blog post. They explain this, if you are a beginner, in a very beautiful way. They tell you what is happening here, how is test time compute scaling here. Yeah, they go with open models here. And they explain even, hey, why is there such a problem if you have, what is larger, 9.8 or 9.11? They explain here the process. So if you are interested in starting from the beginning, test time compute scaling, I think here, currently, mid of December, this is one of the best starting documentation. If you want to see now beyond chain of thought, I have this video here on forest of thought implementation and the test time compute. And of course, if you want to go for the real heavy stuff, those are the two videos for you. But anyway, so you see, this O3 mini now creates in the inference run, in our 13 minutes that we as user, we are waiting for an answer by O3 mini. O3 mini is generating now a lot of possible solution, and you can put all of this solution in a mathematical space. Maybe you embed it here in a vector space or whatever your tensor structure you go with. Maybe you have a Monte Carlo tree search that evaluates here each possible solution. But there are a multitude now, let's say, of solution to my task that I as a human put in here in my prompt. And now for me, and maybe I'm wrong, please help me if you think you found a solution. I understand that now this O3 mini uses here its trained methodology, because it's using now the same reasoning method that it was trained on in the supervised fine-tuning and in the reinforcement learning phase. It is applying now its knowledge how to argue, how to reason, how to deduct in logical steps to come to a conclusion for this same topic. So you see, in this level of complexity, O3 mini maybe was just dealing with particular scientific facts. Now the same O3 mini is dealing with solution complexities, solution scenarios. And now O3 Mini or O3 implies now, or in my understanding, uses here, of course, the same reasoning methodology that was imprinted on the system here in this combined coherence SFT or reinforcement learning synthetic feedback methodology, and it now uses this methodology on this higher complexity data set. And now what's happening? O3 is now reasoning based on those solution sets and saying, hey, this is the best solution set after my chain of thought implementation. And therefore, I can now say, let's say this model or this solution complexity is now the answer to the user prompt. So this is at the current moment, just one day after O3 was released, and having no other documentation by OpenAI than just yesterday's released safety instruction by OpenAI. This is what I understand. This is my knowledge. Maybe it will increase in the next day. So if you are a subscriber or you become a new subscriber, hey, this will be a journey. So you see, there's a very strong dependence now how the inference time reasoning is happening. And a lot of my viewers ask, but what methodology is here? Is this a separate LLM? But O3 is the best one. So what we are using here to decide here in the inference time reasoning process, we don't have a definite answer by OpenAI, and they are the only one to give us here the real answer. But in my understanding, it is that if we train here, before we start here the real task, the real inference, if we train here the O3 or O3 Mini here with particular reasoning methodologies, chain of thought, or maybe in the next evolution, a forest of thought, or whatever comes next, then when we apply the inference time reasoning, we only have those model, and those model is applying what it learned, the inherent methodology, on now a higher complexity data set, and it applies this reasoning methodology to find here the best solution in a higher complexity search space. And for me today, this is my understanding, I need a system coherence. I need a system coherence because if this is true, then how I do the supervised fine-tuning, how I do the reinforcement learning now with a reward system and not with TPO, and how I achieve the inference time reasoning over 13 minutes, half an hour, maybe an hour, this all has to be in a harmonic way. It has to be in a coherent way because I apply here the reasoning methodology I imprinted, I learned the system here. Now to the implementation, and there is some real nice visualization I would like to show you. Yeah, this is the paper here by OpenAI, published yesterday, and they call this, in the safety domain, they call this deliberative alignment. So the reasoning that enables here our O3 models or our O1 models here with the chain of thought reasoning that they implemented, and they give us here some little bit tiny information how this deliberative alignment, DA, is working. And you have here from this publication, you have here now suddenly an open chain of thought, and O1 or O3, whatever, wants to show us here, hey, look, this is the way the system argues internally. Up until now, we were not allowed to see this argumentation process of O1 or O3, but here OpenAI published it itself to show us what is going on for this safety instruction. Yes, you get the idea, and we just look at it and we interpolate it away from a pure safety-related function. The idea is simple. It is the classical one. There's nothing special. Look, we have here supervised prompts here with a safety categories. So we have here a specific data set where the safety documentation is now imprinted here in our prompts. We have here all the specifications that OpenAI decide are important for their model, and then we generate the data, the training data, supervised fine-tuning data generation. Then we have those data, so we take here a simple LLM, we do the classical supervised fine-tuning training, and we have now a new if you want, trained supervised LLM. And then we have the same specification, you see the same safety specification, but now we encode them here in the reinforcement learning prompts. So we, how to say this, we multiply here the safety implementation if you want. We have the classical reinforcement learning training process now with a reward model, and then we have our new safe LLM, O1 or O3. They give us here a little bit more details about how we generate here the supervised fine-tuning data generation. If I have here the safety instruction, you know, this is my document symbol that I just showed you before. Yes, prompt, yeah, just standard, nothing special. And then they look here at the reinforcement learning, how to do this. Yeah, this is exactly the classical way to do it. So they tell us now, and this is here almost here an absolute quote. They say how we do this deliberative alignment training here now with O1 and O3. And they come back to an idea of a process and outcome-based supervision I'm going to explore in a minute, but let's just follow with the argumentation. So OpenAI tells us, hey, we first pre-train here an O3 style model for helpfulness without any safety relevant data. So in their pre-training, they say, we have a pre-trained model, and I understand because this is the most expensive part to train. And they say, then we build here a data set. A data set of pairs where we have the prompt and the completion of the prompt, where the chain of thought in the completion, so here we have our safety instruction built in. We do this by inserting the relevant safety specification text for each conversation in the system prompt. This is nice, so that they take a model, they put here the safety specs in the system prompt, and then the model itself generates here the model completion in the pairs. And then what they do, they just remove the system prompt from the data, and then they are left here with a data set of pairs where you have the prompt and the completion that is now in each specific case reflecting here the safety instruction on the safety specification. And therefore we have here these pairs that are perfect now for the chain of thought implementation, including the safety reference in the specifications. And then we have now the data set. And what we do with this data set, we perform a supervised fine-tuning on this data set that are now including here all the safety instruction here in this particular way, providing the model with a strong prior for safety reasoning. And then they say, and this is important, so through this process that OpenAI applies, the supervised fine-tuning model now learns both. It learns the content of our safety specification and how to reason over them in the simplest version. We have a chain of thought to generate the aligned responses. So you see, we have achieved now, we have the content, and we have the content in a form that is perfect for a chain of thought reasoning procedure. And then they say, hey, we use here the reinforcement learning now to train the model to use its chain of thought more effectively. And to do so, we employ now the reward model of reinforcement learning, which has access to the safety policies, of course. And now this reward model, hopefully an external model, is able to provide now an additional reward signal. So if you have a lot of data, you need here a reward model as a judge. And this reward model chooses now the best answers, the best generated synthetic data that respects and implements the safety policies of OpenAI with this particular additional reward signal. So let's say minus 100 points or plus 50 points, depending here, whatever the reward model judges itself as an AI on the performance data, if it should be included in the training data set or not. Classical stuff. And we have here the conclusion here by OpenAI, and the author is Melody Guan, and here are the other authors, and you find this here, and it is great. But of course, if you want to do a little bit more deep dive and you are interested in science, you go for the original paper, and we have here the paper, Deliberative Alignment, DA, Reasoning enables here safer language model. And since they open up here on the reasoning that is happening here on the O1 and the O3 models, so this was here my entrance door to explore this a little bit more in details. And they say here they use this here for OpenAI's O-series models. So real interesting, brand new information here, although only specified by OpenAI on the safety procedure for reasoning. I think this is a general reasoning pattern that you can implement if you want to build an open source O3 model with some other models. I told you that it is not that easy to read the paper, because if you start to read this paper, you are immediately referenced here to solving mathematical problems here with the process and the outcome-based feedback. And this is an interesting theoretical problem that already was handled here by Google DeepMind in November 2022, because they were asking themselves, hey, should we optimize the model here on the process supervision? Or should we just validate here and evaluate here the outcome of the model? And how should we steer our optimization methodologies? Now we would say for the reasoning process. Should we focus on a process feedback optimization, or should we just focus on the outcome feedback? What is delivering here a better performance? And currently I'm reading this paper to be able to understand the historic roots that OpenAI came up here yesterday with this particular paper. But this particular paper has its own complexity. So if you enjoy my video today, one of the next videos, I will have a deep dive here into this video to further understand all the reasoning processes that are happening in the O3 model and the O3 mini model, because I want to crack it open. I want to understand the inner working of O3, because I think some months we will have an open source O3 model, and therefore we have to understand as much as possible of this closed source model by OpenAI that is currently so amazing. So I hope you have some new ideas with this video. Maybe you become a new subscriber, and it would be great to see you in my next video.